Today we're looking at the 2020 AMC 8, and this is question number 10. Let's read the question together. Zara has a collection of 4 marbles, an Aggie, a Bumblebee, a Steely, and a Tiger. She wants to display them in a row on a shelf, but does not want to put the Steely and the Tiger next to one another. In how many ways can she do this? Okay, so let's take a look. We have A, B, S, and T. So those are the 4 types, right? And we know that the S and the T should not be next to each other. And so it's pretty difficult for us to find how many ways to not have 2 things next to each other. So instead, what we're going to do is we are going to find out how many ways there are to find them next to each other in one unit, and then we're going to subtract that from the total number of arrangements. So those 2 things are going to be a little bit easier to find. So let's group S and T together. We'll call this C. So we have now A, B, and C, and we want to know the number of different ways to arrange 3 things into 3 spaces. So this one's not that hard. So in the first space, we can put in A, B, and C. In the second space, for example, if we picked A for this first one, we can put B and C in the second space. And if we picked B for the second space, this means we have 1 possibility left for the third space. So we have 3 times 2 times 1, which is also known as 3 factorial, right, guys? And so the value of this is going to be 6. But that's not where we stop for the cases with S and T next to each other, because remember, C is just S and T next to one another. And so to fulfill this, we can also have, instead of ABST, we can also have ABTS. So for every 1 possibility here, we can also switch T and S to make 1 more. So taking this into account down here, we say 6 times, and because there are 2 things that we're rearranging within C, the S and the T, we have 2 factorial, okay? And that's just going to be 2. So we multiply 6 times 2, and we get 12 ways, excuse me, for S and T to be adjacent to one another. Awesome. So now remember what I said, we're going to have to now find the total number of ways to arrange 4 objects. Okay, and so we have A, B, S, and T. So in our first slot, we have 4 possibilities, right? We have A, B, S, and T. And so just like we did over here with the 3 factorial, we're going to do the same over here with 4 different things. We have 1, 2, 3, 4 things, so we have 4. So let me rewrite them on the top just so that it makes sense. We have 4 different slots, and we have 4 possibilities here, A, B, S, and T. We have 3 possibilities for this one right here. So if we picked A here, we have B, S, and T. And we have 2 possibilities here. If we pick B here, for example, we have S and T. And for this last one, we have 1 possibility. If we picked S, for example, and so we have T left. So we have 4 times 3 times 2 times 1, just like 3 factorial. This one is going to be called 4 factorial. And the value of this is just going to be 3 factorial times 4, right? So 4 times 3 times 2 times 1 is going to give us 24. So there are 24 total ways. Total ways. So we're going to do 24 minus 12 will give us 12 ways. So just an explanation, this is our total number of ways. And this is ways where S and T are adjacent, which means that what's left is the ways where S and T are not adjacent. And so 12 is going to leave us with answer choice C.